So I think you already know that the first part of this is just simply factoring this function. Whether you need to make a substitution or whether you can factor it without the substitution, that's something I'm going to leave up to you to figure out. I'm going to factor it without the substitution. Okay? So I'm going to go ahead and say that the two factors that I need to make this magic happen are the cosecant of x. Let me give myself a little bit more room here. And I'm going to use theta because the x and the theta are kind of getting in the way a little bit. So I'm going to use cosecant of theta. And in the first place, I'm going to have plus 3. In the second one, I'm going to have cosecant of theta minus 1 equals 0. I'm hoping that everybody is Natasha. Okay, Natasha. Yeah. Try to keep the hall passes to no more than about 5 minutes, please. Okay, so looks like Leanne has just joined us. Leanne, I'm going to go ahead and mark you as being here, but unfortunately at this point in time, you're now late. And we're still looking for Hunayin at some point to join us. Hopefully he will, but let's keep going. All right. So yesterday we said, okay, if you factor it the way we factored it, then we can now use a zero product law. We can now say that the cosecant of theta plus 3 equals 0, and the cosecant of theta minus 1 is equal to 0. That's just a zero product law there. That's a law that shows us or says to us that if I multiply these two things and I'm getting 0, then one of them has to be 0. That's all a zero product law really says. Okay, now we know we have to bring that 3 over to the other side. So the cosecant of theta is equal to, of course, minus 3. That's supposed to be theta. And then, of course, theta is equal to cosecant to the minus 1 of the minus 3. But the question is, how does this cosecant thing work? I mean, first of all, can I take the cosecant to the minus 1 of the minus 3? Is that even possible? Flip the fraction and make it into sine, Brendan says. Right? And Christiana says, change to sine x and take the reciprocal of minus 3, which is, okay, well done. Well done. So before I even go to this point right here, right, I'm going to say, let's back this up a bit, right? Why don't we change this cosecant into what cosecant is, which is 1 over sine. And if I'm changing that to 1 over sine, this is still minus 3, right? All I'm doing is changing cosecant into, excuse me, what cosecant is, which is 1 over sine. And then I can flip the two sides of this equation. This 1 over sine, if I flip it over, will become sine theta. But if I flip over one side, I have to flip the other side over as well. So minus 1 over 3. Okay? So let me just, I know that Christiania follows that, but that was her suggestion in the first place. Is everybody on board with me with that? So the key to this was to take the cosecant and turn it into what cosecant is, and that's 1 over sine. It's still equal to minus 3, but then because it's an equation, I can do the same thing on the two sides. I can flip over the 1 over sine and make it just simply sine. If I flip over one side, I can flip over the other side. Flipping over the other side gives me minus 1 over 3. Let me let that sink in for a minute. Is everybody comfortable with that statement? You know, I like to check in with the room from time to time, so I'm going to do that right now. Let me see. How about Kelvin? Kelvin, does that make sense? Okay, perfect. All right, Donna, Lynette, everybody else was saying yes to that. So now we have to say, okay, that theta is equal to sine to the minus 1 of, and again, I'm going to call this theta prime. That's what I do. I'm going to call this positive 1 over 3. Because as I said to you yesterday, I never asked the calculator to give me an inverse, inverse sine of a negative. I never do that. That's just not the way I do it. Now, if you find it that it's easier for you to do it that way, then fine. But I'm going to call this sine, I'm going to call this theta prime or x prime if you like. And I'm going to say, okay, go to the calculator. This is not one of those special angles, right? Go to the calculator and ask the calculator to give you what sine to the minus 1 of 1 over 3 is. Then we're going to draw a Cartesian plane. And we're going to use that as a deviation from the x-axis. So Cresania is telling me that that works out to be 0.34. So I'm going to say, taking Cresania's word for it, that's approximately equal to 0.34. Now, here is where I'm going to draw my axes. And then I'm going to decide, okay, I need to put that deviation, that gap that I have from the x-axis in the correct quadrants where sine is negative. Originally, it was where sine of theta was minus 1/3. So which quadrants do I need to put that in where sine is negative? Okay, great, Quinn. And Cresania is saying quadrants 3 and 4. Do we all agree on that? Can we make sure we're all on the same page with that? Alexa says yes, and Brandon says yes. I'm going to put my lines in. I usually use red for that. I'm going to put a line here and a line here, and I'm going to put the angle of 0.34 as the angle measured from the x-axis. I didn't hear anybody objecting to when Cresania gave me, was it Cresania? Yes, 0.34, so I'm going to assume that's correct. Okay, so now we have to come up with an angle measured from standard position that takes us to here and also takes us to here. So let's take, first of all, the green line, right? Let's take that green line first, that green angle, and ask yourself, I'm in the third quadrant, right? I'm in that third quadrant. I'm 0.34 away from the x-axis. How do I get that first angle theta, right? How do I get the first one? 0.34 away from the x-axis in quadrant 3. Can anybody suggest what that green angle is? The one I wrote in green. How would I get that green angle? Anybody? Nobody? See, I haven't been using the wheel recently because I'm sort of leaving it up to you to jump in there. Okay, go ahead, please, Chrisania. Oh, I'm sorry. I just, you know what? Sometimes I scroll up in the chat and then I forget that I'm too far up to see what people are saying. Thank you, Chrisania. Thank you for doing that. Yeah, I see Chrisania. Okay, Hussein and Davina, Brendan, and Shebon put all answers in. Hussein, can you see why your answer isn't quite what it is? Can you see why that is? Because we're in the third. Okay, yeah. I'll start with the fourth. Oh, the fourth one. Oh, we'll get to the fourth one eventually. But yes, I'm going to agree with the people who are saying it's going to be pi plus 0.34. Right now, the one in the fourth quadrant, and let's see if what you wrote was right. I'm just saying you're right. It is 2 pi minus 3.4. Yes, and then we're going to go 2 pi minus 0.34 would be the answer for the fourth quadrant. Absolutely. Well, we need to put some actual numbers on that. So that's where only calculators can help us out, right? So the blue one Shearbun says is yes, absolutely. Okay, give me some actual answers now, please, in the third quadrant and fourth quadrant. I have pi plus 0.34 to make sure that I'm seeing what you're putting in. What's the first one? What's the green one actually equal to? So I'm getting 3.48 from Cresania. And let me know if anybody objects to that. And then the 2 pi minus 0.34, what is that? I'm getting 5.94 for that. Thank you very much. Okay, so that's giving me answers from the left side of this zero product law statement. But then we also have to do the same thing on the other one. So let me go through the exact same process again. So cosecant of theta, oh, sorry. The cosecant of theta is equal to 1. I'm just bringing the 1 over to the other side. And then I'm going to state that the cosecant is 1 over sine theta is equal to 1. And then I'm going to flip over the left side to give me sine over 1, or just simply sine. And if I flip over the other side, guess what? It's still 1. It's still 1. Okay, Hunayin has just checked in. All right, so I'm glad you eventually got here, Hunayin, but I will have to mark you late at this point. And that completes our attendance for today. Everybody's now here. That's great. Okay. All right. So again, sine is my y value. So when I'm at numbers like 0 and 1 for sine or cosine or tangent, what we need to do is to draw the quadrant and assume that we're going to be on one of the axes. Remember, my starting point is over here at 1, 0. I did this yesterday. Then I'm going to be at 0, 1. Then I'm going to be at minus 1, 0. Then I'm going to be down here at 0, minus 1. So if I'm looking at this thing within a 300 and, well, I nearly said 360 degrees. Let me take that back. I'm looking at this thing within a 2 pi revolution. Remember, the original question wanted the answer between 0 and 2 pi. What I'm really asking is, where is my y value equal to 1? And I see a bunch of people, Sinduja, Krisania, and Davina, put that answer in. There's only one place that works for sine, and that is at pi over 2. So theta is equal to pi over 2. Now, whenever you're answering questions like this, where some of the answers are decimals and some of the answers are exact value, I want you to give the answers exactly like that. If it is possible to give an exact value, give an exact value. If it is not possible, then you give whatever the decimal is to whatever number of decimal places was required by the question. So here is my final answer. So the answer is, put a little box here, put the final answer here, put them all together. My answers are theta is equal to 3.48, 5.94. These are approximate. And theta is also equal to pi over 2. And this one is exact. Right? So these are the final, let's say, answers. There are only those 3 answers, right? 2 of which are approximate and 1 is exact. So that's it. Right? The secant cosecant thing really isn't as hard as it looks. And hopefully that puts you in a better position to be able to answer a question like that on the homework. All right? Okay, now, little different question. Look at this one. Sine 2x plus 0.5 equals 0. We've never had to solve an equation when there was a 2x before. We've solved it for x or for theta. We never one when there was a 2x or a 0.5x or anything like that. So, any suggestions as to how we might be able to get started on this? Replace sine 2 theta with identity? Nice thought, Hussein. Except I'm not going to do that, right? That's a nice thought. I like that thought, but there's another approach to it, which we're going to do. Bring the 0.5. Oh, yeah, we have to do that as well, which we'll do, right? But Hussein, that would be a strategy that may work for some questions, but we're not going to do that for this one. I'm going to show you how to tackle something where there's a 2x or a 3x or 4x or any other number like that. And again, I'm going to ignore, because in the interest of time, we don't have the time to be able to tackle it. I'm not going to deal with this question of between minus theta and theta. I'm just going to deal with the 0 to 2 pi. We'll just do that one. And I'm going to take Krisania's suggestion to get us started. Yeah, bring the 0.5 over, absolutely. So we're going to say that the sine of 2x is equal to minus 0.5. Okay. Okay. What do you think the next step should say? Any ideas what do you think the next step should say? All right. I agree with it up to this point. Divide both sides by the 2x? No. Because you can't, right? Dividing this by 2, this is not sine times 2x. This is the sine of 2x, right? So that's not the same thing. But what I just saw from Krisania is good. Look at what Krisania just put in. That 2x, this thing that's left here, I'm going to call it 2x prime for now as well, is equal to sine to the minus 1 of, and again, you know what I like to do? Put 0.5. I'm not going to put the negative yet. I'm not going to call it negative yet. Okay? We'll get to the negative part later on. So this 2x prime, right? This deviation from the x-axis is a sine to the minus 1 of 0.5. Okay. Grab your calculators. This is going to be this is one of those special angles. There is a particular special angle that has a sine that gives you a sine of 0.5. Can anybody tell me what that is? Right? What is that angle for? Okay, Chrisania says it's for. Is it only Chrisania? Okay, sorry, I take that back. I was going to say if it's only Chrisania taking the load of the whole class, because I see Brandon and Sinduja have also jumped in. Pi over 6, thank you very much. But the question now becomes, where do I put that pi over 6? Right? That's where the Cartesian thing comes in. I put that, according to Hussein and Brannon, quadrants 3 and 4. Well, you're right. We just had this case of sine being negative. Let's put those two angles in quadrants 3 and 4. So I'm going to be pi over 6 away here and pi over 6 away right there in 3 and 4. And by the way, I should just check in to make sure everybody understands why it is that it's quadrants 3 and 4. Mohammed, how about you? Does that make sense that it's quadrants 3 and 4? Do you see why we're using quadrants 3 and 4? Okay, great. All right, so because it's sine and because it's negative, that's where sine is negative. So now we have to figure out what the actual value of 2x is, right? So that was 2x prime before, but now we have to figure out what that is from standard position. In other words, and I like to put it in this way, starting from here all the way to here, that's one of them. And the other one is starting from here and going all the way around to here, right? Those are the two angles we're trying to figure out. So can anybody, so Chrisania says it's pi plus pi over 6, good. So 2x is equal to pi plus pi over 6. And what's the other one? Actually, she gave us both. What's the other one? No, she gave us one, actually. What's the other one? 2 pi minus pi over 6. Good. And then there's also, actually, let me bring this down. And the other one is 2 pi minus pi over 6. So in real terms, without having to have the pi plus and the 2 pi minus, what does it actually reduce to? How about that first one? Well, actually, Christina gave us that like 10 minutes ago. I'm exaggerating a bit. That was 7 pi over 6, right? How about the second one? 2 pi minus 5 pi over 6 in Duja. No, you want to check that again. You want to check that again. I'm not going to tell you Chrisania is right or Brandon is right. Yeah, okay, it is wrong. Yeah, but I know you know why it's wrong. Okay, you're taking 2 pi, which is like saying, you can think of it as being 12 pi over 6 minus 1 pi over 6. So that would be 11 pi over 6. Okay? So those are exact answers. Now, how about if I told you that those answers are incomplete? Right? Right? That's not the end of the story. Because these are 2x. That's not what x is. That's what 2x is. Right? So what would you do next to figure out what x actually is? Clearly, we haven't finished the question because we've gotten to the point where we have 2x divide by 2. We're going to divide each of these answers by 2. So that means that x is equal to 7 pi over 6. What's a good way to divide a fraction by 2? Anybody think of a good way to divide a fraction by 2? Reciprocal of what? Multiply by a half. Well done, Donna. We're going to multiply that by 1 over 2. You're absolutely right. So let's do that for the first one and do that for the second one. Multiply by a half. That's a good way to divide by 2. All right? So you multiply the fraction by a half. So we have two answers so far for x. One answer is 7 pi over 12. And the other answer is 11 pi over 12. So we don't stop when we get to the 2x part. We go further because we need to get x. Now, do you think we've finished the question? Let me ask you that. Let me go back and show you what the question asked us to do. Give all answers for the sine of 2x plus 0.5 equals 0 between 0 and 2 pi. Would you say that we have this finished at this point? What does the room think about that? Right? Let's see. What does Roma think about that? Roma, you think we have all the answers for this so far? If I were to draw a graph, because graphs can answer these questions for us. If I were to draw a graph, would the graph give us this as the answer, as all the answers? Or what do you think? You sense that I'm kind of pulling you into some sort of a trap here. I kind of by the way I'm asking the question, you smell a rat. That's kind of what you're saying. Isn't that what you're saying, Roma? Right? Mr. Kamak has something up his sleeve. This is not what it's painted to be. Well, you're right. That isn't the whole answer. Turns out that we've only got half of the answers so far. I'm going to show you a graph here. This graph is the graph of the thing that we're talking about right now. And as you can see, we have the two answers, 7 pi over 12, 11 pi over 12. That's where it's crossing the x-axis. But look at that. We said we wanted answers all the way up to 2 pi. Anywhere between 0 and 2 pi. Do you notice that there are two more answers? And that we didn't get all the answers, right? So how come we missed those other answers? That's the question we have to answer, right? We got the 7 pi, it's right here. We got the 7 pi over 12, we got 11 pi over 12, we're good to go, right? But we didn't get this answer, and we didn't get this answer. Can we go up a bit more after? Sure we can, sure we can. I just want to make sure you're clear on the fact that we're supposed to get all the answers going from 0 to 2 pi. Here's 2 pi over here, right? What are all the solutions? The graph is telling us what those solutions are. And two of them are absolutely what we said they were. But right now, we're noticing from the graph that we have some more. We're missing a piece of the puzzle. And we have to ask ourselves, how do we find the other parts of this? How do we get more from this? And when you wanted me to go up a bit, I have gone up. Do you see what you're looking for? Okay. So let me tell you what the piece of the puzzle is that I didn't really sort of let on before. Because it's a 2x equation, and because we're being asked to go from 0 to 2 pi, at some point in the equation, to get our answer, we have to divide by 2, right? Right here, right? When we got to this point, for us to get our answer, we divided by 2. So these answers that we got were really only a half of all the answers that you can possibly get, right? These are answers that are within our domain. Our domain goes from 0 to 2 pi, but because we chopped it in half to get our final answer, we're missing two other answers. So here's what we do. It's very simple. Instead of only going from 0 to 2 pi, we're going to multiply both sides of this domain by 2. So we're not just going to look between 0 and 2 pi. We're going to look between 0 and 4 pi. Because when we divide both of these by 2, which is what we have to do at some point, that's going to bring us back to 0 to 2 pi. So you know what this means? We have to go through that entire circle a whole other time. Because 4 pi means we've done 2 revolutions. Remember, 2 pi is 1 revolution, 1 circle. 4 pi means we have to go through this one more time. So every answer that we got before, right? Instead of just 7 pi over 6 and 11 pi over 6, which are the two answers that we got before, to that, we now have to add in the first answer plus another 2 pi. The second answer plus another 2 pi, which is going to take us back to the same place. Remember, if I do a full circle, I used a term yesterday. Somebody, I forget who it was. Well, I forget who it was, but I remember using the term coterminal yesterday, right? All coterminal means is another angle that's in the same position as the one that you're talking about. So, for instance, let me do a little separate x and y axis over here. So if I was, let's say, for instance, right here, let's say this angle was, I'm just going to make this up, 7 pi over 6. Right? So I've gone past pi, and I'm pi over 6 away, which is 7 pi over 6. In fact, that was one of the answers that we had, 7 pi over 6. If I want to get this same position again, right, after a second revolution, then all I'm going to do is I'm going to go a 360 and then add on another 7 pi over, oh, that looks messy. Add on another 7 pi over 6 onto that. Okay, let me see what you're saying here. So 3 pi over 6 minus pi over 6. You could do it that way, yes. Or just simply, okay, let's go ahead, Quinn. Sure. The domain was 0 to 2 pi. You're asking me to scroll up to the domain, just repeating your question. And I'm saying we're going to double that. We're going to look within 2 revolutions. We're going to not just look after one revolution, one circle. We're going to go again and look in another circle. So we're going to go past the point that we would normally stop at, which is 2 pi, and we're going to go through again another full circle. But we're going to end up at the same place. We want to end up at the same place as we were before, right? So what we're saying, so Christiania says, it's like saying 3 pi minus, yes, it is. Or just simply, you're right, I'm not going to dispute what Christiania says. It is, in a sense, the same thing as just taking each of the first angles that you got, 7 pi over 6 and 11 pi over 6, and adding 2 pi to both of them. That works just as well. Okay? But yes, Christiania would be the same thing as 3 pi plus pi over 6. That would work. Or 4 pi minus pi over 6. That works as well. So the other two angles that we didn't get before, if we use Christiania's approach, which is 3 pi plus pi over 6. Now think of 3 pi as being 18 over 6. That's 3 pi, right? 18 plus another pi over 6 give me 19 pi over 6. Oh, sorry. So that's 19 pi over 6. And then think of the last one as being 24 pi over 6, which is the same thing as 4 pi, minus pi over 6, or take 11 pi over 6 and add a 2 pi to that. Either way, right, it's going to get me 23 pi over 6. Okay, hopefully everybody sees that. Does that 23 pi over 6 make sense to everybody? All right, I just want to be sure. Let me check in with the room on that. Okay, Brandon says yes. Alexa says yes. Where's everybody else though? Does 23 pi over 6 make sense as our fourth angle? So our third angle, well done. So our third angle is 19 pi over 6, and our fourth angle is 11 pi over 6. I could easily get this by adding 2 pi onto that. And 2 pi is like saying 12 pi over 6. So 12 plus 11 gives us a 23. So that means that we now have 2 more angles to take and multiply by a half. We have the 19 pi over 6 times a half. And we also have the 23 pi over 6 times a half, which means here are all my x values now. I don't want to have anything missing. Let me get rid of this. I should now have 19 pi over 12 and 23 pi over 12. Those are all my answers. And if we go back and look at the graph, that's exactly what the graph says. But of course, you can't read that because it's so messy. Let me get rid of all of that. There's my 19 pi over 12. There's my 23 pi over 12, which goes along with 11 pi over 12 and the 7 pi over 12 that we had before. So all the answers are exactly what the graph is telling us. And all answers are between 0 and 2 pi. And I do that one more time, just as last two. Absolutely, Quinn. Absolutely. So how did we get the 19 of pi over 6 again? Okay. Here's the easy way to do it, Ryan. You see the two answers that we got the first time? The 7 over 6 and 11 pi over 6. You see those two answers? And in fact, I'm doing this not just for Ryan and for Quinn, but for everybody else. Remember how we got, just if that part makes sense, take those two answers and add another 2 pi onto them, right? So it's like saying the following. So we have what? At 7 pi over 6. So 7 pi over 6 plus 2 pi, put 2 pi over 1 if you like. Get a common denominator of 6. So this would be 7 pi plus, think of this as being 12 pi, right? You know how to get that, right? And that would give us what, 19 pi over 6? Does that make sense, Ryan? Okay, that's good. And Quinn, how far back do we need to go? I mean, just go ahead. Oh, one at a time, please. Okay. Okay. Sure. Sure. So, so remember. Okay. Let me ask you this: the 7 pi over 6, 11 pi over 6. Were you okay with that part? Did those answers make sense? And Donna, I'm definitely going to get to you after this. Did those answers make sense? The first two answers that we got. Right. Yes. 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 Okay. So, and by the way, you know why we're multiplying by a half? Since it's 2x is equal to those things, multiplying by a half is the same thing as dividing by 2. Shaban, I'm going to get to your question as well in a minute. Does that make sense that multiplying by half means the same thing as dividing by 2? Okay, perfect. So all we did, you see the two answers that we had first is 7 pi over 6 and 11 pi over 6. I added 2 pi onto both of those. Because adding 2 pi onto those two takes us right back to that same position after having done another full circle. A 2 pi rotation is a full circle. So I'm adding another 2 pi onto the original answers to take me back to that same position after having done another full circle. Do you see why I'm adding on that 2 pi there to get another answer in the same position after I've done a full circle? Does that make sense? Okay, perfect. And then, of course, we multiply those answers by a half as well. Okay, so Sheban wants to know about the 23 pi over 6. 23 pi over 6, remember the other answer we got was 11 pi over 6. So let's take that 11 pi over 6 and add on the 2 pi onto that. Common denominator there, of course, is still 6. So it's 11 pi plus 12 pi. Plus 12 pi. And that gives us a 23 pi over 6. Okay, Shiabon, does that make sense? Are we good now? Okay, great. All right. So I'm going to do another one that's similar. So here are our answers. All answers are there, right? I'm going to do another one like that. By the way, this other graph that's down here is to answer the question between minus pi and pi, which we didn't do. If we have some time, which I doubt we'll have, I may at some point tackle that. We're not really going to focus on that too much because we just don't have the time for it. Let's try this one. There is no identity. Well, that's not true. I was going to say there is no identity for a half x. There is an identity for a half x. When I asked the question before, I think it was Hussein who was suggesting we use an identity for the 2x. But we have obviously found a different approach to it. Let's try the same thing here between 0 and 2 pi. I want to get all the answers, all possible answers between those 2 points, 0 and 2 pi. Before we go any further, how far do you think we should be looking for our answers? Anybody have an idea? So right now the domain is 0 to 2 pi, right? How should we adjust that for when we're searching for our answers? Anybody suggest where my search should be for when I'm looking for answers? Remember, it's a half x, right? My original domain, so 0 to pi. Well, look at you, Chrisania. Well done. I'm actually going to go from 0 to pi. And why am I doing that? I'm halving both of these terms, right? I'm taking a half of 0 and a half of 2 pi, right? At some point, I'm going to be actually multiplying my answers by 2 because of the 0.5x. So that's why what we're doing is we're halving our domain. Okay, let's get to it. Let's get to it. And I'll show you the graph in a little while to show you that the graph is saying the same thing. Why are we taking a half, Ryan is asking? Because in the previous question, let me delete this. In the previous question, when it was 2x, remember that we multiplied both sides of the domain by 2? So instead of 0 to 2 pi, we started looking at 0 to 4 pi. Do you remember that, right? So we're doing the same thing here, except in this case, It's a half x, right? So we're taking a half of 0 and a half of 2 pi. Make sense? Okay, you're welcome. All right, so let's just treat it as if that was not the case yet. We'll just go through all the steps you normally go through, which is to take the 4 cosine squared of a half x and set that equal to 3. And then let us divide both sides by 4. Cos squared 0.5x is equal to 3 over 4. I'm just going through the normal algebra, nothing fancy here. We've done this before. Then we're going to take the square root of the two sides. So cosine of 0.5x, forgot the x, cosine of 0.5x is equal to the square root of 3 over 4, which is equal to the square root of 3 over 2, but plus and minus. Plus and minus. Okay? So we're now looking for where the cosine of 0.5x is equal to root 3 over 2 plus and minus. Stop me if I'm going too fast. I want you to stop me if I'm going too fast. Okay, this is a special angle. So 0.5x, what I call prime, is equal to some special angle. And I don't know what it is. I've admitted that before. I'm going to say it's probably pi over 6, but I could be wrong. Okay, Brennan is, thank you, Alexa. Thank you, Brennan. I think it's pi over 6, and I'm pretty sure you're right. Okay, so my question now is, which quadrants should I be looking in? Now, remember, this is plus and minus. So, all of you who said all, Chrisania, Hussein, Brendan, Quinn, are all right. So we're going to do exactly that. I usually use red for that. So I'm going to go looking in all 4 quadrants. I'm going to put a pi over 6 everywhere. Pi over 6 there, pi over 6 there, pi over 6 there, and pi over 6 there. Okay. Except that that's wrong. Why is that wrong? It's right for what we normally do, but it's wrong for this question. You didn't see that coming, did you? Right? So the actual values of x, right, the 0.5x, let me come down here now. Come back to the blue. So 0.5x itself is equal to, where should I actually look? I'm not looking in all 4 quadrants. I just wrote in the marker. Okay, never mind. Davina says quadrants 1 and 2, and she's right. Why? Yeah, I did get you. I did. Why is it only quadrants 1 and 2? Why is it only quadrants 1 and 2? Kelvin, oh, Kelvin said something there. Let's see what Kelvin said. We don't consider clearing purposes. Oh, I didn't even see that, Kelvin. Because we only want to get up to pi. I didn't realize that Kelvin had spotted that earlier. All right? He is absolutely right. So although normally we would go in all quadrants, our search only can go, and I'll put a green thing here. We can only go from here up to here because we said that we can only go from 0 to pi. Now, there are other answers, but not in our domain. Our domain sticks to, if I said, give me all the possible answers, yeah, I don't really care about the domain, then yeah, we're going to go in all 4 quadrants. But if I want to go from 0 to pi, right, then I can only look in the first 2 quadrants. Now, my answers will still be between 0 and 2 pi as my final result, but I can only search between 0 and pi. So let's get back to where we are. So my first answer is obviously, hopefully obviously, still going to be pi over 6. My second answer is going to be what? Remember, I can only go in the second quadrant now. So pi over 6 away in the second quadrant would be what? right? Remember, quadrants 1 and 2. We have this first quadrant answer already. What's my second quadrant answer? Oh, it looks like it's a yeah, nobody's got that answer yet. I had to scroll down quickly so I wouldn't miss your answers. So pi minus pi over 6, absolutely. So pi minus pi over 6. So 0.5x is equal to pi over 6 is 1. This one, hope everybody is agreeing with me, is 5 pi over 6. Okay? Good, Christina. Well done. But now we have to actually get the actual answer, which is x itself, right? We're not looking for 0.5x, we're looking for x. So how do we isolate that x? Go on, folks, you can do this. How do we isolate x? Multiply by 0. No, Chrisania, no. We don't multiply by 0.5. We multiply by the reciprocal of 0.5, which is multiply by 2. Okay? You see that, Chrisania? I know you know that already. Right? So remember, it's really like dividing by a half, and dividing by a half means multiplying by the reciprocal of a half, which is 2. So really what we should have is this, pi over 6 times 2 over 1, if you like. The other one should be 5 pi over 6 times 2 over 1. Okay, hopefully that makes sense. And then that gives us our answer, if you reduce that down, of pi over 3 in one case, and 5 pi over 3 in the other. I'm just reducing it down to its lowest terms. Does that make sense to everybody? Want to make sure you're good with that before I go any further. Okay, good. Sherbon, Brendan, and Davina. I have a graph to bear me out on that. Here's my graph, right? Again, I only care about answers from here to here, from 0 to 2 pi. And you can clearly see from the graph that the only two answers that we're getting are the two answers that we just got. The pi over 3 and the 5 pi over 3. Those are within the 0 to 2 pi, right? And we didn't search between 0 to 2 pi. We didn't go in all four quadrants as we sort of thought we would initially, right? We left out these two because these two would actually be out. When you multiply by 2, then this one and this one would actually be outside of our domain, outside of the 0 2 pi domain. Okay? All right. I'm going to ask you to show me that you understood what we just did. It's your turn. Can I see the final answer? Oh, sure. Final answer is right there, pi over 3 and 5 pi over 3. Right? And the graph is telling us the same thing, pi over 3, 5 pi over 3. No. I don't do this often enough. Wouldn't it make pi equals 2 pi on the graph since we multiply by 2? Brendan is asking. Wouldn't it make pi equals 2 pi? No, okay. So we didn't multiply by 2, we multiplied by a half. The original, and I'm glad you asked the question. When we did this the first time, it was a 2x, and we took the 2 and multiplied both sides of the domain by the 2. So we got 0 and 4 pi. In this case, I'm going to look at, maybe I should read your question more carefully. Would it make pi equals 2 pi on the graph since we're multiplying by 2? So it would be like saying x in quadrant 2 equals 2 pi similar. Well, let's put it this way, Brenda. Let's put it this way. We always, even though our answers will still be inside of the required domain, when we're searching for the quadrants for answers to come from, we always multiply by whatever this number is here in front of the x. In this case, it's a half. It's a half times 0, a half times 2. Okay, we're looking at the graph. You look for values between the original domain. Well, if you have the graph in front of you, yes, but you're not expected to have the graph. You're expected to be doing this algebraically. So, yeah. All right, Hussein. All right, we're doing this algebraically, so we don't have the graph necessarily in front of us. All right, okay. Now, it's your turn. All right, so I'm going to go ahead and move this thing aside and show you that you're 100% right. See if we can put the application of trigonometric functions to good use. People who live in Canada, like ourselves, know that it's very seasonal, right? So that would mean that certain things that are related to the seasons tend to follow a trigonometric kind of pattern. Here's an example. The sales, of Raoul's heating oil are seasonal. Monthly sales can be modeled by, and you see what the equation is. S here represents the average monthly sales, and X represents the months of the year. So for instance, January is 1. If I put 1 into this equation for X and work it through, it will tell me what his sales are for January. If I put 2 in, that will be February, and so on and so forth. When are his sales less than $4,000? Well, first thing I did is I drew the function, right? I mean, we're going to do this algebraically, but I took the liberty of using a graphing program, WinPlot. Some of you know WinPlot's an older program. And I drew in the function. I also drew in the line for $4,000. So this red line here is the function. The blue line represents the $4,000 mark. So clearly, his sales are going to be less than $4,000 in between these 2 months. What months are these? Month 5 and month 8, when it's not really that necessary for you to have heating oil, obviously. So between months 5 and 8, from the graph, we can see that the sales are dropping below 5,000. Somewhere in month 1, right, is when it's kind of at its peak. Somewhere back in month 12, it's also back at its peak. But it's trending down and drops below the 4,000 mark at some point and goes back up. So here's my function. 1600 cosine pi over 6x minus pi over 12 plus 5100. That is the function. So how do you think I can figure out where this thing is less than 4,000? Well, first of all, the question is, can we figure out where it's equal to 4,000, right? How can I use the equation to figure that out? When is this function, 1600 cosine, etc., equal to 4,000? Because once we figure that out, then we can figure out where it's less than 4,000. So what do you suggest we do to set this up so we can solve this practical problem, right? How do we do that? Anybody? How do we set this up? That's the function that tells you sales. So his sales are dictated by this equation. We want to know when his sales are 4,000. Set it to $4,000. Absolutely. We're going to do exactly that. So I'm going to go ahead and say that 1600, cosine pi over 6 minus pi over 12 plus 5100 is equal to 4,000. Right? So the equation equal to 4,000. Absolutely right, Kusanya. Absolutely right, Hussein. So let's use our equation solving techniques now to solve this. Where would I go next to solve this? Right? How would I isolate, oh, I'm missing an x, am I not? Yeah. How would I isolate that x which was missing all along? How do I isolate that x? What's the first step in isolating the x? Take the 5100 away from the 4,000. Good, we'll do that. So 16,000, I keep saying 1,000, 1600 cosine pi over 6x minus pi over 12 is equal to the 4,000 minus 5,100. And that's too many zeros. Okay. Your Wi-Fi disconnected. Okay. So obviously we can now do that simple step and say that 1600 cosine is pi over 6x minus pi over 12 is equal to minus 1100. What's next? Divide by 1600. Thank you, Cristiano. So cosine of pi over 6x minus pi over 12 is equal to minus 1100 over 1600. So far, so good? Are we all on the same page here? Does that all make sense? Dividing, good, okay. So now what? Now what do we do? We use the cosine to the minus 1. Wow. So we're going to say that this thing inside of the bracket, this thing here inside the bracket, the pi over 6 x minus pi over 12 is equal to cosine to the minus 1 of, I'm not going to use negative, I'm going to use positive, 1100 over 1600. You know how we do it. I'm going to call this prime for now. I'm going to call this prime for now. So remember, to get rid of the cosine, we use the cosine to the minus 1. All right. So in the 5 minutes or 6 minutes that we have left, let's see if we can finish this up. I need you, so let me put the pi over 6 here quickly, x minus pi over 12. I need you, prime, to tell me what cosine to the minus 1 of that is. It is negative, Jenna, but remember that I've never asked you to find cosine to the minus 1 of something that's negative. So you're right. I've always said leave the negative until afterwards so you can figure out which quadrant to put it in. Remember that, Jenna? So right. So we're going to stick to that convention. We're going to keep going with that. Okay. So I'm not sure if everybody agrees with Crisania's 0.81. Does that make sense, everybody? 0.81, the cosine to the minus 1 of 1100 over. Okay, so I'll put that in. So 0.81 is what she got. And now we're trying to figure out where to put that. Can somebody help me out with that, please? What quadrants are going to make sense so that cosine can be negative? The negative cosine now. So 2 and 3. All right. So here and here. I'm going to put my 0.81 here and my 0.81 here. All right. That's where cosine is negative. So Jenna, that's where my cosine being negative comes into the picture, right? When I figure out what that deviation is, when I find the cosine to the minus 1, then I put that deviation in the quadrant that is relevant, is how I've been doing this. So now we have what the pi over 6 x minus pi over 12 is actually equal to. So the second quadrant answer, right? Hopefully, in the interest of time, I'm going to kind of rush this along a little bit. Is going to be pi minus 0.81 and also pi plus 0.81. I want to make sure everybody agrees with that before I go any further. Does that make sense? That I'm adding on a pi and I'm minusing a pi for the quadrants 2 and 3. Okay, perfect. So it's a little bit of work that we have to do to finish this up. Remember, this is pi over 6 x minus pi over 12. Give me what those two answers are, please. What is the pi minus 0.81 and what is the pi plus 0.81? Give me those two answers very quickly, please. I'm running rapidly out of time here. We may have to finish this question up tomorrow. So 2.33, and what's the other answer? Please, quickly. 3.95, okay. But that's not what x is. How do we get x? What's the next quick step to get x? Come on, folks, help me out. It's pi over 6 x minus pi over 12 is equal to these two numbers. How do we get x on its own? What do we do with the 2.33? What do we do with the 3.95? What do we do with those numbers? That's the question. Can anybody answer that question quickly? Sorry to be rushing you along, but bring the pi over 12 over. So add that pi over 12 over. And then what? Yes, Davina. Yes, you're right. And then what? Then we do one other thing after that. Because that's only pi, then divide by pi over 6. Well done. Okay, so let's do it for one of them. So pi over 6x is equal to the 2.33 plus pi over 12. Okay, so quickly answer that question for me, please. 2.33 plus pi over 12. What is that equal to? Again, just give me two decimal places for now, just in the interest of time. 2.3. And again, I will probably do this again tomorrow because I need to finish up the question anyway. But let's just see if we can finish at least one part of it right now. So 2.33 plus pi over 12, what is that equal to? Quickly, folks. Come on, anybody. 2.33 plus pi over 12. 2.59. Okay, 2.59. So it's pi over 6 x that's equal to that. So x should be equal to 2.59 times 6 over pi. Remember, we're going to multiply this side by the reciprocal, right? So the 2.59 times 6 over pi. So can you quickly tell me what that number is? 4.95. Thank you. So that apparently is this answer that we got right here, right? That's the 4.5, 4.95. All right, I'm going to leave it there, right? We clearly have to finish up this question tomorrow. And then we'll probably try to tidy up the stuff in trigonometry, any loose ends that I'd like us to cover in trigonometry. I'll probably do that tomorrow so that by Friday, we can start our work with logs and exponents.